And a soak running and running. A while.
It's like loop.
Yeah, it's a loop. If we normally we loop and loop. So let's show you. Last time we started experience 7. Oh. This is an interrupt example. Here is a row. Follow me. While. This is a while and endless loop. Just like this model. Endless loop. While. Run and run and endless. Look, don't end. Okay. Then we let our LED off if the flag is 0. And we let the LED off. We distinguish the LED. If flag is 1, yes or no? If the flag is 0, then we let the LED on. Else, we let the LED off. Loop and loop. I want to ask you, when and why the flag will be changed? We don't change the flag. Yes or no? We don't change the flag, but the flag will be changed in somewhere. Yes or no? So I ask you, during this running, we don't change the flag here, but the flag will be changed at somewhere. Yes or no? Where do you think the flag be changed? Where the flag be changed? We don't change it in our own program. We don't change it. But in fact, the flag does be changed in somewhere or at somewhere. I want to ask you where the flag be changed. Can you guess? Or do you know? Okay, let's see here. If you remember, last class we modified this code, this subcode. We changed it to let this code simple or easier to read. Yes or no? Here, the flag B changed, and here, the flag B changed. In this line, the flag changed to 1, and here, changed to 0. Okay. The next question: Why this function is called? Who called it? When the subroutine is called. If we get the answer, so we can
in the main program needs to be called by flag.
No. Let me see. We don't call it. We only use the flag to let the LED on or off, to let us to see the phenomenon clearly. Yes or no?
This function in the target initialization function.
Well, here
In that function.
this function.
Yeah.
This is only an initialization.
Yeah.
It only executed once. One time.
In that function, that timer function included in the if you in this function, in that function, then you can see that timer function. That timer function called in that function.
Well, in this function, we call this function. Do you think so? Do you think this function is called by atomic initialization?
Yeah.
No. So I say the interrupt is fairly difficult. The last class we started a timer and interrupt. Two knowledge block. Let's see. Last class, we learn timer. We learn timer. In the timer, we define the period time, 1 second or 2 seconds. Yes or no? We calculate the time, we measure the time.
And divided it several times.
Yeah. And today, we will study another chapter, interrupt. And the software, let's see. This is a interrupt demo. It collaborated timer and interrupt. Two knowledge. Yes or no? Last time we studied timer, and this class we are going to learn interrupt. But the software, the project, is composed by two knowledge, tunnel and interrupt. Yes or tunnel, the tunnel will let us get how to measure time, just how to measure time. But the interrupt tell us how can we interrupt CPU. The CPU is running and running. If something arrives, interrupt the CPU will stop the current task and enter the more urgent event we call interrupt. Okay. So, if something occurs or around, we will stop the current routine. And this is also a program or a routine or function. Anything as you will. You want everyone knows. It is also a program, a segment program or routine or software. Here we call this one is the main routine. Running. Okay? And this one we call the RSR. Do you know ISR? Do you hear about ISR before?
Interrupt segment routine.
Yeah. Pardon? Interrupt what?
Segment.
No segment. Service. Yeah, service. Routine. Interrupt. ISR is interrupt service routine. Yeah, routine is also a segmented program. It's also a program, but it's special. When an event is around, we stop. The CPU will stop the current task and to respond to more urgent event. Let's play a game. Give me your mobile. Look, close. Okay. The screen is bright. If we press this button, sorry. Press it. Then the CPU will be quick. Yeah, will be quick. So this press is an interrupt. This is an interrupt. If you don't have the interrupt inception, it may be hard to understand it.
Like there if they are regular routine, if they are regular task, if I force to do something urgent, this called interrupt, right?
Can you look? When shall we press the button?
When you need.
Sorry?
When I need.
When you need. As a software engineer, I don't know when. You will press the button. Yes or no? So this is a very interesting knowledge. Can you tell me what is the point? What is the point?
Telling something
required Oscar continue. Yes or no? I give you example. Give you an example. In our class, we have tutored 3 students. Only students, 3 students. We can get the point is inconvenient. But if normally we have a lot of students. You see this classroom. In my class, there may be more than 100 students in a class. Usually, I want to know if the student understand my lesson. I will ask you. I'll ask her. I will ask the student. Do you understand? He answered me, yes, I understand. Then I will ask the next student, do you understand what I said? He maybe also yes, I understand. Then I will ask the next, one by one. More than 100 students. Do you think how long I will spend to ask one by one? Maybe more than 1 hour. Yes or no? So when we ask of all the students, I will say, okay, so much for today. Yes or no? So if I am a CPU, my efficiency is very, very low. Yes or no? are continually asking all the students one by one. This is polling. This is polling. Then okay, hello, the efficiency is too low. So we change the rule. Change the rule. I will tell all the students. I will have the class continually. I won't stop to ask if you understand. And I suppose that every one of you understand what I said. So I don't ask you. But if you, for example, logic, you have a question, you don't catch me, you don't keep up with us. So I say, if you don't understand me, you can put up your hand and say, teacher, please wait. I don't catch you just now. For example, I don't know what is calling. Please tell me. Okay? This time, I will stop. Stop here. I don't run. I stop here. And to answer Maury's question, I will answer your question. After I answer your question, this here I answer Maury's question. After I answer Maury's question, I return back to the point. Continue management. Do you think the same time my efficiency is more high? Yes or no? For you see, most students understand my method. Maybe only one or two. You can. So also, you can interrupt me by putting your hand. If I see you hold your hand, then I will stop the lecture, enter the ISR to answer your question. After I finish the task, I finish your interrupt service, I respond to your interrupt, I will go back to the lesson. In this model, the CPU will go back to the main routine to continue running. So the CPU's efficiency is very high. It won't waste the time just by polling. Yes or no? Okay. Here you go about. Okay. The CPU just do its normal work. Won't stop. Because it does one and the hook will press it. So he do its normal work. Then will ask if you press, won't answer the button. So this is interrupt. So interrupt the efficiency is very high. I just demo you. The CPU has normally two run style. One is polling. Just ask the component, external component or external device. If you have data, if you are ready, for example, the key. If you are pressed by someone, just point. If you point all the time, so the CPU's efficiency is very, very low. Yes or no? It's very, very low. So we use the second step. The CPU just run at your will to perform its normal task. Need to stop. Need to query, to ask all the components. Needed.
Okay, I am going to interrupt you. I want to know about the polling again. About polling.
Polling. Just the demo.
Yeah.
Polling.
Yeah.
Okay. I said, if we have in our class,
just if you can tell it shortly.
Shortly. What?
Shortly. Just little, you can just tell me about polling.
Oh, okay. Polling is ask the I read the demo. This CPU and here is key. The key is a slow device. Yes or no? The CPU is a very fast device. So, normally, how can we get the key is pressed or not? How can you learn? If you are CPU, how can you learn? The key is pressed or locked. So you should continually check this pin. If the key is not pressed, the pin's level is high or low. Is high or low? Not pressed.
If not pressed, is low.
Low, high,
or high.
Higher. Yes or no? It's higher. If this key is pressed,
It's low.
so yeah, this point and this point is connect together. So this is ground. So you will get a low level. Yes or no? Unpressed, high level. Pressed,
Low level.
low level. I want you to tell me, how can the CPU get the key is pressed or locked? How can?
By continuously checking.
Yeah, continually checking. This time, do you think it is a waste of time it may waste a lot of time. Because you don't know when the key is pressed, that's your key. You don't know. So you waste a lot of time to get the information. Whether the key is pressed. But if we change the rule, don't ask. If you have event, you need to talk to me. So this is another mechanism. Okay, so this is wrong. The another mechanism is interrupt. This efficiency is a very efficiency. CPU efficiency point is low, is very low, and the interrupter the high, because an agent continually to check the other device. If you have event, you can interrupt me. Interrupt me. If you interrupt me, then I will stop here. I stop. Anyway, if you at this time, I will stop here and go back. You don't know when and where. So the CPU is efficient. So, interrupt. The ISR will be called by interrupt mechanism. Not normally calling. Okay, I will. So this is the ISR.
Interrupt service routine.
Yeah, this is ISR.
Interrupt service routine for timer.
Yeah, you're right. Interrupt the timer. Not cross. We stop the timer.
Yeah.
We counting by 10, 9, 8, 7 to 0. When it reaches 0, the generator interrupter. Let's see. Yes, you're very good. Okay, let's see. Here, on here. Look at here. Timer. Last class. Each timer has its own ceasing down counter, which is driven by timer clock. When the down counter reaches 0, the timer interrupt request is generated. Interrupt is generated. Yeah, to inform the CPU that the timer operation has been completed. Yes, so now the software is composed by timer and interrupt.
Just send a notification in the CPU.
Yes,
is done.
Yes, the timer operation is completed. So it interrupts the CPU. Okay, let's see. Let's see this demo. The CPU normally running, continually running is the main rule. When the timer down counter reaches the 0, so the interrupt the CPU, interrupt somewhere. Enter where? To enter here. Enter here. So it changed the flag. So the main rule. If the flag changes to 1, we remain the LED on. If the flag is 0, we off the LED. So you can see the LED is breaking off and on. Yes, and periodically. What period? The timer is running. Timer is measure the time. Period. Very
like 1 second.
Yeah. 1 second. Interrupt.
After 1 second, it's interrupted.
Yeah, 1 second interrupt. 1 second. Every second. If you want 2 seconds, you just set the timer to 2 seconds. We lost the timer. We have started it. You can set the period time as you will, anytime. When the timer is over, it will interrupt the CPU. We will enter this ISR. In the ISR, we change the flag. We can make it more simple. Can you understand? Please see. Follow me. Speed. Change to This is more simple. Just 1 to 0 to 1. Is also the same function, but this is more simple. Okay. So in our ISR, we only change the flag. Okay. Here, we want to show you why how the interrupt works. This chapter may be fairly difficult, so you should listen carefully. Okay. The real-time performance of embedded system is a very important feature. Interrupt enables the processor to process the event when it occurs, instead of continuously calling whether there is an event. The operation efficiency of the system is improved. The main content as follows. Interrupt is a hardware mechanism that notifies the processor that an extraneous event has occurred. Once the interrupt is identified, the processor's value saves some all the registers at the breakpoint. What is breakpoint? This is the breakpoint. This is breakpoint interrupted by ISR. Okay. And dropped to a special subroutine. We call it interrupted service subroutine. So this is ISR. After the interrupted service subroutine completes the event processing, the CPU returns to the program breakpoint to continue running. To improve the CPU's efficiency, you didn't continually ask or point all the events. This is a model. The CPU have more than 30 interrupt source. What is interrupt source? Can you guess what is interrupt source? I say this key is an interrupt source. And the last class, the timer 1, is an interrupt source. Yes or no? And the timer 0, timer 1, timer 2, timer 3, 6 timers are all interrupt sources. Yeah. So what is interrupt system? Interrupt system is external device or internal function block. There will be arise or interrupt signal to inform the CPU that a more urgent event should be processed.
Yeah. Lakshmi, I have one question. Like,
please.
I am typing something to send message something. That time, like some who call me, is that interrupt, right? Like I am typing, and that time is calling someone.
Yeah.
That is interrupt, right?
Yes. You are send a message.
Yeah, I am typing. We playing games.
Playing, yes.
Yeah. Like I am playing games.
Yeah.
That time he calling me.
Yes.
Yeah.
That is interrupt. You didn't ask. Whenever someone is calling me, you don't ask. You even didn't ask her whether Modier is calling me. If they call you, will arrive and interrupt. So you play your game around. If the end of the call, you go back to continue.
Yeah.
Continue to play your game. Yes. All else, your CPU will waste a lot of time to ask or to point. Yeah, continuously ask to check whether he call you. Whether he call you. You didn't do this. Okay. 30 source. I will show you the source. Here. Timer 0, 1, 2, 3, 5, 4, 5. Yes or no? And then here, external 0, maybe a key or other external symbol. I will tell you. This is UART, receive data. The previous next two class we have learned the UART. Yeah, UART receive. You don't know how the data route. Yes or no? You don't, because you don't know. You don't know when the data will send it to you. Don't know. So you can only continually ask the status of register whether a data is coming. Yes or no? Let's see the program. Let's see the program. You are calling. Please look at here. You are calling. The order is you are to interrupt. Let's see the you are calling first. Okay. Please. This you are to get. Do you remember? Do you still remember? Why? If there is low data, the CPU will continuously ask the status register whether a data is arrived. Let's see the here. If a data coming, then we will execute this sentence, or else continue calling here.
Asking the status.
Yeah, whether a data is coming. If no data coming, so the CPU stop right here. Nothing will do. Just to
asking.
Yeah, asking if a data coming. This is very bad. Today, if we learn the interrupt, we'll change it. You can do your work.
Yeah.
You needn't care if our data is coming. Okay, let's see. This register. We can search. Here. This is the receive box data ready. Status register. If this bit is 0, complete and loaded coming. If this bit is 1, the box register has received the data. Yes or no? So because we don't know whether a data is coming, whether a data is coming, I don't know, because you connect your personal computer with your device. You don't know when this data will arrive. So you continually ask the status register whether a data is coming. If loaded, so you do nothing. Just asking. Yes, it is very tricky. So, do you think it is wrong?
No,
it is good. No. So, we change to interrupt. You do your own work. If loaded is coming, you do yourself. The CPU is continuing to run your normally working. To your normally working. If a person is coming, the UART receive will interrupt it. So you won't miss every data. You won't miss every data. So just like you won't miss any code your friend of your friend. Yes, okay. So the interrupt is good. The point is simple, but the efficiency
is not good.
Yeah, is low. The CPU's efficiency is low. Okay. So if you learn interrupt, you can change your code to use interrupt style. Okay. So all of this is 30 interrupt source. 30 interrupt source. Here is you want to receive data. Yeah. And if you receive the data, you can interrupt the CPU. You generate interrupt request generate to stop the CPU, to influence the CPU. The CPU will stop and enter your ISR. Okay. I will show you another knowledge. This is the interrupt vector address. Can you guess what is a vector address? Can you guess what is a vector address? This is very useful.
Like a virtual address? Is it like a virtual address?
Botnet. What is botnet?
Address. Virtual address.
Address.
Yeah.
What's the address? What address? What is address? Please follow me. All of these are interrupt sources. 30 interrupt source. Next standard, time one. Every interrupt source has its own vector address. The corresponding vector address. For example, time one. If time one arrive a code, it will generate an interrupt request. So the PC
program counter.
Yeah, the PC will be set to this data, this value, but hardware. The PC will be set to this value, the corresponding value. If time 0 will be 60, if time 1 will be 64. One is the first. Have 4 bytes. So this is the entries of the interrupt service routine. I just asked you, how can the ISR will be called? It is not be called. Now let's tell you. If this interrupt around, the PC will be set to this value, but otherwise it will be set to this value. Okay, let's demo it. Open the power on the device, and we debug it. We find the ISR. Find this. We set up breakpoint at here. This is time 1 ISR. Okay, let's go. We delete this breakpoint. Alright. Enter the ISR. We run again. Again
is
enter the ISR. Oh, we say the ISR is called. Okay, that's wrong. Just wrong. Again. So every time or every second, the interrupt occurs. So it will enter the ISR. So enter the ISR, we change the flag. So the main loop has change the flag. So it will let URL will be on or off periodically. Yes or no? Okay. I just want to demo you. If the timer 1 interrupt, the PC will change to this one. Please look carefully. Then we can set a breakpoint at 6:4 to check if it true. That's all right. Because teacher has told you, when the timer 1 interrupt, the PC will be set to what? To 6:4. Yes or no? Yes or no? So let's check whether it is true. Look at this table. Timer 1. If timer 1 is interrupted, the vector address is 64. So we set a breakpoint. I will show you. We can find where is 34. We can't know. We don't need to know. We just press open this view and just input breakpoint. Or you can set only to BR is breakpoint. BR. Just set a breakpoint at 64. If the PC, if the timer interrupt is generated, the PC will point to this yes or no. Okay, next enter. Okay, let's see whether here has a breakpoint. Yes, here has a breakpoint. We can delete this. Just remain only one breakpoint. Okay. We close this and close this. Here we can close. Let's run. Here the interrupt runs. Yeah, the PC, because time 1 generates the interrupt. So the PC, let's see PC. The PC has to be changed to 64, but hardware. Don't buy software anything. Can't buy software, just buy hardware. Forced to be a fixed address. Every interrupt source has a unique address.
Vector address.
Yeah, vector address. Okay, let's just continue. Keep the CPU step by step. Then you see what you see. Okay, step by step. Sorry, there may be some error. I'll do it again. I see whether the breakpoint here. Yes, here has a breakpoint. Let's break here. Okay, let's step by step. Sorry, they have something error. Maybe something error. I will check. Okay. Okay, look at me. Look at here. Carefully. Let's around interlock. Okay. Here. And we step by step. Step 1, step 2, 3, 4, 8. To end the ISR. Yes or no? To end the ISR. So the ISR is executed. Then over here, let's see. It will go back to the main loop. Look at it carefully. Yes or no?
Yeah.
Back to the loop, main loop.
Main function.
Yeah, main function. Back. So when interrupt occurs, it will let the PC to be a fixed address, and then will end the ISR. After finish this code, it will go back to the breakpoint. Go back to the breakpoint continually to run. So if someone call you are playing game, someone call you. So the answer call. Just continue to play your game. Yes or no? Okay. Let's continue. And how can we control the machine by software? Control we want to learn. Because you all are excellent software engineer in future. So you should learn how to control your machine by software. So this is very important for us. For us, we should learn how to control it. We use interrupt. Okay? Let's continue. We should learn several registers. The first one is interrupt control register. Just like the time control register. Just like the GPIO configuration register. GPIO data register. Yes or no? Okay, another register is interrupt suspended register. And interrupt mode register. And interrupt mask register. Very interesting. Okay, let's continue. The first register is interrupt control register. This register has only 3 bits. How about only 3 bits? The bit 0 is a fast request. The bit 1 is runner interrupter. And this bit is 0. We select the vector interrupt model. So when timer 1 is generated, the PC will be set to 64.
Yeah.
This is a vector. This is vector model.
Vector mode.
Yeah, vector model. We should select a vector model. So, and we enable normal interrupt request. We don't use fast interrupter. So, we select 0, 0, 0, 0, 1, 0, 0, 1. Let's see our source code. Can you see it? This is register. We should select.
Interrupt.
Yeah, 0, 0, 1. So it's a 1.
There are 3 registers: interrupt controller, interrupt mode, and interrupt mask.
Yeah, this register.
Controller.
Yeah, control register.
Yeah.
2, 1. 1, the hex 1. Hex 1 is 0, 0, 0, 1. Finally. Yes or no? Why we set 0? Or set here. 0, 0, 1. Interrupt the control register. Okay? This is the first register. And then another register is a pending register. What is pending register? How one asks, how can a software engineer learn whether an interrupter source is generated interrupt? How can you learn whether which interrupt source has occurred? You don't know. Okay, this register total 26 bits. Every bits for one interrupt source. For example, time 1. On bits is 12. On bits 12. If the bit is 0, long interrupt request. If 1
is requested.
Yeah. This interrupt source has generated. Let's see. This register. What the address is? Here. We copy it. And we what's the memory? We just paste the address into it. Close this. This is a 0004. Okay. And this 000, 001, 002, 03, 00 here. 12 speed. 12 speed is well. You can write down this data. Write down this data, this value first. Write down it. Or picture it. Take a photo. Take a photo. Shoot it. Or write down. Remember the current value. 0C 10 0000. Okay? That's wrong. That's wrong. Okay. Wrong. Here how okay. The no interrupt occurred. 0C 00. Let's do it again. Here, this beat is the 12th beat. You can calculate yourself. So, when the time of 1 occurs, the 12th bit will be set to 1. Okay? Each of the 26 bits interrupt pending, corresponding and interrupt source. When an interrupt request is raised, it will be set to 1. It will be set to 1. The interrupt source routing must then clear. Look at this line carefully. The interrupt source routing must then clear the pending condition by writing 1 to the corresponding bit of another register. This is very difficult. This is very difficult. First of all, we have learned if an interrupt occurs, the corresponding bit of the pending register will be set to 1. Yes or no? To inform the CPU that an interrupt has occurred. Yes. You are engineer. You are software engineer. You should yourself to clear this bit. Yes or no? If you don't clear, the interrupt come again. So when an interrupt comes, enter the interrupt service routing. You should clear it. Not by yourself.
There we after that one is to make garbage value.
Yes.
Right.
Sorry.
After generated.
Yes, generated. Yes.
SC1, right?
Yes, 7 to 1.
Yeah. If we don't clear it,
then if you don't clear it,
if there
it will repeatedly enter ISR. So you need to clear it by hand, by your software. How to clear? Read this sentence carefully. The interrupt source routing. Inside the interrupt source routing in ISR, here. this line. At the end of ISR. Yes or no? At the end of ISR. This is ISR, interrupt service routing. In the interrupt service routing, let's look here carefully. In interrupt service routing, must then clear the pending condition by writing walk to the corresponding bit of another register whose name is RSPC. Interrupt the service pending clear.
Pending clear is finished.
Yeah. Okay, let's see. Let's see it again.
Yeah, it's finished.
Here. Now this is the one. This is the bit. The bit is one.
Yeah.
Okay. Look at it carefully.
It's 0.
0. Cleared. Just by this sentence. How can we do this? We will explain it for you. Okay. This is very difficult. Let's see this macro definition. This one is 1 left shift 12. 1 left shift 12. Because let's see. The time 1 is 12. Time 1 is 12. Okay. So here let only the 12th bit is 1. The other bits is all 0. So we write this data. Write this data to this register. This register RSPC. I will show you. RSPC. Here, tell you that you clear the tendency by writing 1 to the corresponding bit of this register. So, if you learn how to read the data sheet, then you can write your software. Yes or no? This
represents in the data sheet.
Yeah. So you should learn how to read the data sheet of CPU. If you understand the data sheet, then you can write software. Okay. So here is the register. This is the register. We can find this register. Here, the register RSPC, the 12th bit for time 1. Okay. Another register. Another very interesting register. Interrupt mask register. Can you guess what is the purpose of intermask? I want to ask you. Do you set your alarm in the morning? You set? No. Inside the sound. Do you close it? Look, you don't close. Don't close the alarm on Saturday or Sunday. Then in the morning, it will wake you too early. Actually, from Monday, Tuesday, Thursday to Friday, I will set an alarm to wake me up at 6. But I close it on Saturday and Monday. Tomorrow I will close my alarm.
But you know.
Yeah, I don't want it's very important for me.
But you know, we are Muslims, so we have to pray early.
Yeah.
So every day we need alarm.
Yeah. Yes.
So wake up and pray.
Yes. Okay. So this register can help you to shut down or close the interrupt. When you need it, you can open it, or else you should close it. Okay? How can we say? This register interrupt the mask. Just like your network address mask is also a mask. Okay? Time 1, tell. If 0, service available. If 1, then will be masked or be closed. It won't work. The interrupt won't work. So if you enable an interrupt, you should make this bit to what? To 0 or to 1. If you want to open,
if you want to open it will be 0.
Yeah.
If no it is there 1.
Yes. Okay. And every interrupt source have a bit, have its own bit. So let's see. Oh, sorry. Just a minute. Here. Open the interrupt. Just the back. This is intermask register. Just by rec 0. This is the 1. And here, bitwise vote 1 to 0, 0 to 1. Yes or what? So please follow me. What this bit for? This bit, global bit. Look at here. This is the global, and this is local. If we all the power, yeah. So okay. So you see, you can mask locally to close one interrupt source. If you set this bit to 0 to 1, you close all the interrupt source. Okay? So this is very easy. We should in this initialization, time initialization, to set here. And this is our ISR. To let this function to put to this register, and we have finished the interrupt setting. This one is okay. So you can read it yourself. Okay, so much for today. Next week, you come to this classroom to take the open book examination. The